Alright, let's go. Number 10. The Vela Incident and the Death from Above. In the height of the Cold War, the United States was paralyzed by a specific paranoia that the Soviet Union was conducting secret nuclear tests in the vast emptiness of space, violating the Nuclear Test Ban Treaty of 1963. To monitor this threat, the United States launched a series of satellites known as Vela. These machines were designed with a singular grim purpose: to detect the unique pulse of gamma radiation released by a nuclear detonation. They were the watchdogs of the apocalypse, staring into the dark to ensure humanity wasn't about to extinguish itself. On July 2, 1967, the veil of satellites screamed. They detected a flash of gamma radiation so intense, so overwhelming, that it washed out their sensors. The military panicked. The signature looked like a nuclear explosion. But the triangulation data didn't make sense. It didn't come from Earth. It didn't come from the far side of the moon. It came from deep space. For years, this data remained classified, buried in the Pentagon's archives because, well, the implications were just too confusing to process. When astronomers finally analyzed the data in 1973, they realized they had discovered something far worse than a Soviet bomb. They had discovered gamma-ray bursts, or GRBs. Before this moment, we viewed the universe as a relatively static, slow-moving machine. Stars lived for billions of years and died in predictable supernovae. But the Vela discovery shattered that illusion. A gamma-ray burst is honestly the most violent electromagnetic event in the universe since the Big Bang itself. In a single second, a GRB releases more energy than our sun will emit in its entire 10 billion-year lifetime. The horror of this discovery lies in the randomness. These aren't just explosions. They are focused beams of death, like a cosmic sniper rifle. If a hypergiant star collapses into a black hole within a few thousand light-years of Earth and happens to be pointing its pole directly at us, we would never see it coming. The radiation travels at the speed of light. There would be no warning. No telescope could spot the precursor in time. One moment, the sky is blue, and the next, the upper atmosphere is instantly incinerated. The ozone layer would be stripped away in seconds, exposing the surface to lethal solar and cosmic radiation. Complex life would be sterilized. The discovery of GRBs changed astronomy because it forced us to accept that the universe is not a garden, it's a minefield, and we are walking through it blindfolded, realizing that at any second, a beam of light launched thousands of years ago could arrive to turn our history into ash. Number 9. The Great Attractor. In the 1970s, astronomers began the tedious task of mapping the cosmic microwave background radiation to measure the motion of the Earth relative to the rest of the universe. We know the Earth orbits the Sun orbits the center of the Milky Way, and the Milky Way is moving toward the Andromeda Galaxy. But when the data came back, the numbers didn't add up. Something was wrong with the math. The Milky Way, Andromeda, and the entire Virgo supercluster, millions of galaxies were moving sideways. They were being dragged through the cosmos at a staggering speed of 600 kilometers per second, over 1.3 million miles an hour, toward a specific point in the sky. Astronomers looked at that point, located the constellations of Hydra and Centaurus, hoping to see a massive cluster of galaxies or a super-dense object explaining the gravitational pull. They saw nothing. The region was obscured by the zone of avoidance, the thick band of dust and stars from our own Milky Way that blocks our view of the universe behind it. We call this anomaly the Great Attractor. This discovery introduced a terrifying scale of cosmic horror. To generate enough gravity to pull the Milky Way and millions of other galaxies at such velocity, the Great Attractor must contain the mass of tens of thousands of galaxies. It is a gravitational anomaly so colossal it defies our models of cosmic structure. Later observations with X-ray telescopes managed to peer through the dust and found the Norma cluster. But even that wasn't massive enough to account for the speed at which we are moving. There is something else behind it, something bigger. The Shapley supercluster was identified further out, but even that doesn't fully explain the flow. We are caught in a river. Every star you see, every galaxy in our local neighborhood is flowing like debris in a flood toward a mysterious drain we cannot see. The universe is not expanding uniformly in our corner. It is being sucked toward a monster hidden in the dark. The Great Attractor changed modern astronomy by revealing that our galaxy is not floating aimlessly. It is being hunted. We are falling toward a gravitational M hundreds of millions of light years across, and we have no way to stop it, and no way to see what awaits us at the bottom of the well. Number 8. Pulsars, the zombie lighthouses. In 1967, a graduate student named Jocelyn Bell Burnell was analyzing data from a radio telescope in Cambridge. She was looking for quasars, but she found a ghost. The telescope picked up a signal, a radio pulse repeating with terrifying precision every 1.33 seconds. It was so regular, so artificial in its rhythm, that for a brief window of time, the scientific community held its breath. They labeled the signal LGM-1. LGM stood for Little Green Men. The possibility that we had intercepted an alien beacon was real. It changed the atmosphere of astronomy from observation to potential contact. But the truth, when it was finally uncovered, was arguably more nightmarish than aliens. It wasn't a signal, it was a star, but a star that had been crushed out of existence. Bell had discovered a pulsar, a type of neutron star. When a massive star dies, it collapses. If it's not heavy enough to become a black hole, it crushes protons and electrons together until they merge into neutrons. The result is a sphere only about 12 mi wide, the size of a city, but containing the mass of the sun. The conservation of angular momentum causes this city-sized ball of dead matter to spin at insane speeds, some rotating hundreds of times per second. The discovery of pulsars introduced us to the concept of extreme matter. A teaspoon of a pulsar would weigh 1 billion tons. If you dropped a marshmallow onto the surface of a neutron star, it would hit with the force of a nuclear bomb due to the gravity. But the real horror is the magnetic field. These dead stars emit beams of radiation from their poles. As they spin, they sweep these beams across the cosmos like a lighthouse. This changed astronomy because it proved the stars don't just die peacefully. They turn into zombies. They become mechanical monsters, clocks made of degenerate matter that will tick precisely for billions of years. We realize the galaxy is littered with these spinning corpses, sweeping their radiation beams across the dark. If Earth were to be caught in the beam of a nearby magnetar, a highly magnetic pulsar, it wouldn't just be radiation poisoning. The magnetic field would be so strong, it would dissolve the electron bonds in your DNA from light years away. You would simply unzip at the atomic level. Number 7. Dark matter and the Vera Rubin anomaly. In the late 1970s, astronomer Vera Rubin was studying the rotation of spiral galaxies, specifically the Andromeda Galaxy. According to Newtonian physics and everything we knew about gravity, stars at the edge of a galaxy should orbit slower than stars near the center, just like Pluto moves slower than Mercury. The further out you go, the weaker the gravity. So the slower you must move to stay in orbit. Rubin found the impossible. The stars at the chaotic frozen edges of the galaxies were moving just as fast as the stars near the core. In fact, they were moving so fast that they should have been flung out into deep space. By all known laws of physics, galaxies shouldn't exist. They should fly apart like a spinning carousel that's going too fast. The only explanation was that there was more gravity holding them together. A lot more. To explain the speed of these stars, a galaxy needed to have 5 to 6 times more mass than we could see. But there was nothing there. No gas, no dust, no black holes, just empty space. This was the confirmation of dark matter. This discovery fundamentally broke our ego. Before Rubin, we thought atoms, protons, neutrons, electrons were the stuff of the universe. We thought we were the standard. Dark matter proved that the matter we can see, touch, and interact with makes up less than 15% of the total matter in the universe. The rest is something else. A ghost substance that passes right through us, doesn't interact with light, and only reveals itself through gravity. We are the anomaly. The visible universe. Every star, every planet, every nebula is just the glowing foam on top of a vast dark ocean. We don't know what it is. It might be WIMPs, weakly interacting massive particles. It might be AXI, or it might be that our understanding of gravity is fundamentally wrong. But the horror remains. We are surrounded by invisible giants. Enormous halos of dark matter engulf every galaxy, holding them captive. We live in a universe where the majority of reality is completely invisible to us. A shadow realm that dictates the structure of everything while remaining forever out of reach. Number 6, the accelerating universe. Throughout the 20th century, the question wasn't if the universe would end, but how. The consensus was built on gravity. The Big Bang blasted everything apart, but gravity is the great unifier. Eventually, we believed the gravity of all the matter in the cosmos would pull everything back together. The expansion would slow down, stop, and reverse, leading to the Big Crunch, a cyclical, perhaps eternal universe. In 1998, 2 independent teams of astronomers studied distant Type 1a supernovae, standard candles used to measure cosmic distance, to calculate how much the universe's expansion was slowing down. They found the opposite. The data was undeniable, and it was terrifying. The distant supernovae were dimmer than they should have been. They were further away than the math predicted. The universe wasn't slowing down, it was speeding up. Why? Something was pushing the galaxies apart. A mysterious repulsive force that grows stronger as space expands. We named it dark energy. This discovery didn't just change astronomy, it destroyed our hope for the future. It confirmed that the universe is dying. Because of dark energy, the expansion will accelerate forever. In a few trillion years, all other galaxies will move beyond our cosmic horizon, traveling faster than the speed of light away from us. Their light will never reach us again. Future civilizations born in the Milky Way will look up and see nothing but their own stars. They will believe the entire universe is just one island in an infinite void. They will have no way of knowing the Big Bang happened, no way of knowing other galaxies exist. And eventually it leads to the big freeze or heat death. Stars will burn out. Black holes will evaporate. The universe will become a cold, dark, expanding tomb where absolutely nothing happens forever. Dark energy proved that our universe is not a cycle of rebirth. It is a one-way trip to oblivion. Number 5, the rogue planet nightmare. For centuries, our definition of a planet was defined by its relationship to a star. A planet orbits a sun. It bathes in heat and light. It has a year. In 2012, astronomers discovered DDA 21249043. It looked like a planet with the mass of Jupiter, but it was nowhere near a star. It was drifting alone, untethered in the deep freezing void of interstellar space. This was the confirmation of rogue planets. And once we knew what to look for, we realized they were everywhere. Computer simulations and gravitational microlensing studies now suggest that there could be billions of them in the Milky Way alone. In fact, some models suggest rogue planets might outnumber the stars themselves. This changes the galaxy from a collection of lit solar systems into a crowded dark room. These are worlds of eternal night. No sunrises, no seasons, just a surface temperature near absolute zero, drifting silently through the abyss. The horror is not just their existence, but their origin. These planets were likely born in solar systems like ours, but were violently ejected by gravitational interactions, flung out by a sibling planet or a passing star. It forces us to realize that the solar system is not a stable clockwork mechanism. It is a chaotic billiard table, and the threat is immediate because they are dark. We cannot see them until they are right on top of us. A rogue planet could be entering our solar system right now, and we wouldn't know. If one were to pass close to Earth, its gravity could tear our atmosphere away, trigger massive earthquakes, or fling us out of the solar system to join it in the darkness. We are sitting in a house with no lights on, knowing the billions of silent intruders are walking through the rooms. Number 4, the monster at the center. For a long time, the center of the Milky Way was a mystery, shrouded by thick dust clouds in the constellation Sagittarius. We knew stars orbited it, but we couldn't see what they were orbiting. It was a heavy, silent, blank spot. In the 1990s and 2000s, astronomers Andrea Gay and Reinhard Genzel used infrared technology to peer through the dust. They tracked the orbits of individual stars like S2 near the galactic core. These stars were moving at millions of miles per hour, whipping around a single point in space, like moths circling a flame. But when they zoomed in on that point, there was nothing. No light, no surface, just a gravitational pivot point with the mass of 4 million suns squeezed into a region smaller than our solar system. We had confirmed Sagittarius R, a supermassive black hole. This discovery changed astronomy by confirming that galaxies aren't just collections of stars, they are gravitational drains circling a monster. We now believe almost every major galaxy has a supermassive black hole at its heart. The horror lies in the scale and the mechanism. Sagittarius, a star, is currently quiet, meaning it's not actively feeding on massive amounts of matter. But it's there. It is the anchor of our existence. The only reason our galaxy holds together is in part due to the formation processes linked to these beasts. But they are temperamental. We have observed other galaxies where the central black hole wakes up. When they feed, they become quasars, blasting jets of radiation that can sterilize their host galaxies. We are orbiting a sleeping dragon. If a star cluster wanders too close to Sagittarius A star, the sleeping giant could ignite, blasting our galaxy with X-rays and gamma radiation. We are living in the orbit of a dormant apex predator. Number 3, the cold spot and the multiverse bruise. When the WAP satellite mapped the radiation left over from the Big Bang, the CMB, in the early 2000s, it produced a heat map of the infant universe. The map showed tiny temperature fluctuations, hot spots, and cold spots, which eventually grew into galaxies and voids. The theory predicted these spots should be randomly distributed and relatively small. But there was a mistake, or so they thought. In the southern hemisphere of the map, there was a massive cold spot. It was huge, about 1.8 billion light-years across and significantly colder than the surrounding universe. It defied standard statistical analysis. The probability of it existing by chance was less than 1%. Astronomers tried to explain it away. Was it a supervoid? A massive region with absolutely nothing in it? Maybe. But even a supervoid shouldn't create a temperature drop that steep. Then came the bubble collision theory. This is where astronomy turns into existential dread. Mathematical physicists Laura Mersini-Hton and others propose that our universe is not the only one. We exist in a multiverse like bubbles floating in a cosmic foam. The cold spot might be a bruise. It is the evidence of a collision where another universe bumped into ours billions of years ago. If this theory holds, it changes everything. It means our universe is finite, contained, and vulnerable. It means the laws of physics are local to our bubble. And it means there are things outside the universe. We are not the entirety of existence. We are just one fragile membrane floating in a higher dimensional bulk. And if we hit another universe once, we can hit one again. The next collision could be catastrophic, wiping out our reality in an instant. Number 2. The Scout. On October 19, 2017, the Pan-STARRS telescope in Hawaii spotted a faint point of light moving across the sky. At first, they thought it was a comet, then an asteroid, but the trajectory was wrong. It wasn't orbiting the sun. It was coming from above the ecliptic plane at a hyperbolic speed. It was the first interstellar object ever detected passing through our solar system. We named it Oumuamua, Hawaiian, for Scout. But the discovery wasn't the scary part. The data was Oumuamua. It was weird. It was tumbling, not spinning. It was shaped like a cigar or a pancake, 10 times longer than it was wide, a geometry never seen in natural asteroids. It had no tail, meaning no outgassing of ice. But then, as it passed the sun and began to leave, it accelerated. It pushed away from the sun faster than gravity alone would allow. Since it had no gas tail like a comet, there was no visible propulsion. The only natural explanation was outgassing of invisible hydrogen ice, a theory that barely fits the data. The alternative proposed by Harvard astronomer Avi Loeb is the one that keeps us awake. The acceleration matched the profile of a light sail, an artificial object pushed by solar radiation pressure. Oumuamua changed astronomy because it broke the quarantine. For the first time, we had to look at a moving object and seriously ask, is this technology? If it was natural, it was a 1 in a billion statistical freak. If it was artificial, it implies the galaxy is teeming with probes. It came, it saw us, and it left. It didn't try to communicate. Why? It treated us with the same indifference we treat a colony of ants on the side of a highway. The scary part isn't an invasion. It's the realization that we might be so insignificant to a galactic civilization that they fly right through our living room and don't even slow down to say hello. Number 1. Vacuum decay. The false vacuum. The most horrifying discovery in modern astronomy didn't come from a telescope, it came from a particle accelerator. In 2012, scientists at CERN announced the discovery of the Higgs boson, the God particle that gives matter its mass. It was a triumph of human intellect. But hidden in the mass of the Higgs boson, specifically around 125 gig-electron volts, was a doomsday prophecy. The mass of the Higgs suggests that the vacuum of our universe, the empty space itself, is not in its lowest possible energy state. We are in a false vacuum, or a metastable state. Think of a ball sitting in a small valley on the side of a mountain. It seems stable. It stays there. But there is a deeper valley further down. If the ball gets a hard enough kick, it will roll over the ridge and plunge into the lower valley. In quantum mechanics, that kick can happen spontaneously through quantum tunneling. If this happens, a bubble of true vacuum will form. Inside this bubble, the laws of physics would be different. The constants of nature would change. Chemistry would be impossible. Atoms could not hold together. This bubble would expand at the speed of light. Because it moves at the speed of light, we would never see it coming. There is no warning signal faster than light. One moment you are reading this, the next the laws of physics that hold your atoms together cease to apply. You, the Earth, the Sun, and the galaxy are instantly deleted. This discovery changed astronomy because it introduced an expiration date that we cannot read. The universe is not stable. We are walking on thin ice over a deep, dark ocean, and the ice could crack at any point, anywhere in the cosmos. It could have already started 1 billion light years away. And the wall of nothingness is rushing toward us right now. We will never know. We will just cease to be. The universe does not care if we understand it. It does not care if we survive it. It is vast, it is violent, and it is hiding things in the dark that defy our nightmares. Okay, that's it for this one. If you want to keep staring into the void until it stares back, hit that subscribe button. I'll see you in the next one.